Product. That means to times numbers together. So the product of 3 and 2 is 6. Prime numbers. That's a number which is only divisible by itself and 1. So prime numbers, they don't really appear in the times tables. So it kind of excludes all even numbers, apart from 2 actually. 2 is a prime number, because every other even number is divisible by 2. Other prime numbers, we have 3, 5, 7, 11. None of these appear in any of the times tables, apart from their own times table and the 1 times table. Now, when we go through the lists and we look at prime numbers, it turns out that all of the prime numbers only end in 3, 7, 9, or 1. Anything ending in a 5 after 5 is within the 5 times table. Because if we look at the 5 times table, it goes 5, 10, 15, 20, 25, 30, and you can see the 5s repeating. Factors. That means a number which goes into another number. So if I wanted to think about a factor of 6, for instance, I've already said that 2 times 3 is 6. So the product of 2 and 3 are 6. Then both 2 and 3 are factors of 6. And in fact, this is the product of prime factors for 6. 6 is equal to 2 times 3. That's quite a simple one to do. We can just split it into these two primes and times those together. Every single number can be written as a product of prime factors. You could say that these prime numbers are basically the building blocks of other numbers. You could say that if you wanted to. Index form. An index, that's basically an indice. So we have x to the power of 2 is 2, that's the indice. Index form, that's when I have, say I had 2 squared times by 3 to the 4 times by 5 to the power of 3. Then this is index form, because I've got numbers when I've got these indices up here. So I want to try and write 36 as a product of prime factors. Now there's a method we can do for this one, and that's called a factor tree. So if I take 36, I can split this into multiple factors. I can say that this is 6 times 6. These aren't primes yet, so I can go further than that. I can split this 6 into 2 and 3. And I can split this 6 into 2 and 3. And I can circle my primes at the bottom of the tree. So if I want to write this as prime factors, I could write it as 2 times 3 times 2 times 3. Let's do a bit of rearranging and collect together the 2's and the 3's. And then we could put them in index form. So instead of 2 times 2, we can have 2 squared, and we can have 3 squared instead of 3 times 3. Let's just check this works. So 2 squared is equal to 4. 3 squared, that's equal to 9. And if we do 4 times 9, that does give us 36. So that appears to work. Now it doesn't actually matter which factors you pick out here. So if I wanted to do an alternative one over here, and I was to have 36, and I wanted to split that into 3 and 12. I circle that prime as I go. 12 I could split into 6 and 2, or 3 and 4 if I wanted to. Again, it doesn't really matter which order we do this. And then I split the 6 into 2 and 3. You'll notice I still get the same prime factors down here. So index form must be 2 squared times 3 squared.